Our lesson today is going to allow us to continue practicing with the distributive property, and in our first example we're told that the school is planning to add a weight room to the gym. It says to use the diagram below to write an expression that could be used to find the total area of the gym and the weight room. And so we see our diagram right here. This was the original school gym right here, and this is the room, the weight room, that they want to add on after the construction. And so we're asked, what is the shape of the gym and the weight room? And so if I look at this picture right here, all right, the gym and the weight room all together forms this shape, which we know is a rectangle. Okay, so the shape of the gym and the weight room is a rectangle. And they want to know, what is the formula for the area of a rectangle? And there are two different formulas that you could use. You could either use area equals base times height, or you could use area equals length times width. Either one will be fine. And then they want to know, what is the total length of the gym with the addition of the weight room? And so if we just look at our original gym, we can see right here, this was the school gym, and it had a length before of 90 feet. And this is the added weight room, and right here they've defined the length to be X feet. It's some unknown length at this point in time. And so if I want to get the total length, I've got to take the original 90 feet that the school gym was, and I need to add on this length that is going to be the length of the weight room, whatever X happens to be. And so what is the total length of the gym with the addition of the weight room? Well, it's going to be 90 plus X, however much that happens to be, feet. 90 plus X feet. And so they want us to come up with an expression to find the area of the gym and the weight room. Okay, and again, remember, it's a rectangle. In order to find the area of the rectangle, we do base times height or length times width. We just saw right up here that the length is going to be 90 feet plus X feet, and the width is down here at 55 feet. And so if I put this together as an expression, I'm going to do the area equals, okay, well the width is going to be that 55 feet times the entire length of 90 plus X feet. Okay, and so this is an expression that I could use to find the area of the gym and the weight room, 55 times 90 plus X. Question B asks us to use the expression to calculate the total area of the gym and the weight room if the length of the new weight room is going to be 12 feet. So I'm going to use my expression that I had up here. The area is 55 times 90 plus X. 55 was the width times 90 plus X is the length. And they've told us that the length of the new weight room is going to be 12 feet. So instead of using X like they had in the diagram above, we're going to replace X with 12. So let's go ahead and substitute 55 times 90 plus 12. Okay, and I can use the order of operations in order to evaluate this, since I can do 90 plus 12 in the parentheses. 90 plus 12 is 102. So I'm just going to do 55 times 102 in order to get my answer. So if we set that up, 102 times 55, 5 times 2 is 10, 5 times 0 is 0, plus 1 is 1, 5 times 1 is 5, 0 placeholder, and again 5 times 2 is 10, carry a 1, 5 times 0 is 0, add 1 is 1, 5 times 1 is 5, and if we add this together, 0, 1, 6, 5, we get 5,610 square feet. Okay, the area of the gym and the weight room is 5,610 square feet. In example 2, we're told that a family farm plans to add a blueberry patch to the end of their apple orchard. What is the total area of land that will be covered by the blueberry patch and the apple orchard? Okay, so this is a similar example to the weight room and gym example that we just did. Here's the apple orchard, and we can see it had a length of 2.5 kilometers. And this is the proposed blueberry patch that they want to add on to the end of the apple orchard. And notice they don't tell us what that length is. And so we're going to use a variable to represent that. Why don't we use B for blueberry? Okay, this length from here, the end of the apple orchard, to here, the end of the blueberry patch, we will call B. Okay, and so we're going to try to come up with an expression to represent the area of the apple orchard and the blueberry patch. So again, all together it's rectangular. So we're going to have to do the length times the width again, just like we did before. And looking at the width of each right here is 1.5 kilometers. So we're going to do 1.5 kilometers times the entire length, which we're going to call B plus 2.5 kilometers. 2.5 kilometers was the length of the original apple orchard plus the added length of the blueberry patch B. So we're going to call that B plus 2.5 kilometers. And we could use the distributive property to write this in a different way. If we did 1.5 times B, B has a coefficient of 1, plus 1.5 times 2.5, this is going to give us a new expression of 1.5B plus 3 7/75. So this could be used to represent the area of the apple orchard and the blueberry patch. In example 3, they want the expanded form of the expression 3 6/10 times t plus 5. And I can't combine what's in the parentheses because I've got a variable term and a constant, so my only option here is to use the distributive property. So I'm going to go ahead and do that. I'm going to do 3 6/10 times t. T has a coefficient of 1, so 1t, plus 3 6/10 multiplied by 5. And now I'll go ahead and multiply. 3 6/10 times 1t is 3 6/10 t. 3 6/10 times 5 is equal to 18, so I'm going to have plus 18, giving us an expanded form of 3 6/10 t plus 18. In example 4, we're using the distributive property to expand the expression x times negative 2 minus 5/10 y. Again, I can't combine what's inside of the parentheses because I have a constant and I have a variable term, and so I have to use the distributive property. And notice what we're going to distribute in this case is a variable. Same process as before. Whatever's on the outside is going to multiply each term on the inside. So the first thing we're going to do is x times negative 2, and then we're going to do plus x times negative 5/10 y. Okay, and remember, x has a coefficient of 1, so we can put a 1 in front there, we could put a 1 in front there. 1x times negative 2 is just going to be negative 2x, and 1x times negative 5/10 y is going to be negative, so we're going to write minus 5/10 x y. Okay, 1 times negative 5/10 is negative 5/10 times the x times the y, and so there is our expanded form. Example 5 is very similar to example 4. We're going to expand the expression t times negative 1 2/10 w plus 3. Again, I can't combine what's inside of the parentheses because I have a variable term and a constant, so I'm going to distribute, and I'm distributing a variable. So we're going to go ahead and distribute the t. T times negative 1 2/10 w plus t times 3. And again, you can give t a coefficient of 1. 1t times negative 1 2/10 w is negative 1 2/10 tw. We list the variables alphabetically. And then 1t times 3 is just positive 3t. So we get the expanded form of negative 1 2/10 tw plus 3t. Example 6 asks us to simplify the expression negative 1/3 times t minus 2 minus 3x plus 3 two different ways. Okay, and so the first thing that comes to my mind is to use the distributive property, and so that's what I'm going to do here on the left. I'm going to distribute negative 1/3 to each term inside of the parentheses. So I'm going to start by doing negative 1/3 times 2, which I'm going to write as 2 over 1 because this is going to make my multiplication easier. And then negative 1/3, so minus 1/3 times negative 3x, and again I'll make it negative 3x over 1, and then minus 1/3 times positive 3, and again I'm going to make that 3 over 1. Okay, and so now I'm going to go ahead and do my multiplications. Negative 1/3 times 2 over 1. Nothing simplifies, so I'm just going to multiply. All right, 1 times 2 is 2. 3 times 1 is 3. Negative times positive is negative, so this is going to be negative 2/3 as our first term. Okay, looking at the second term here, okay, again, I'm going to see if I can simplify before I multiply, and I can in this case. I have a 3 in the denominator and the 3 in the numerator, so I'm going to simplify both of those into 1s. Each 3 is going to become a 1. And now I'm ready to multiply. Okay, 1 times 1x is just 1x over 1 times 1 is 1. And a negative times a negative is positive. So this is going to be plus 1x over 1. Okay, and now I'm looking at my last term here. I have negative 1/3 times 3 over 1. And again, these 3's that I have in the numerator and denominator can simplify into 1's. And so this is going to be 1 times 1, 1 times 1. All right, so each one of these is going to be a 1, 1 over 1. And a negative times a positive is a negative. Okay. So now I'm just going to simplify here what I can simplify. This is going to stay as negative 2/3 plus 1x over 1 is just 1x minus 1 over 1 is just 1. Okay, and I'll rearrange my terms. I like my variable term out front, so 1x minus 2/3 minus 1. And I have constants here that I can simplify. Negative 2/3 minus 1. The signs are the same. They're both negative, so I'm going to add these together. So I'm going to have 1x, and then negative 2/3 and negative 1 is negative 1 and 2/3. And so that's what I'm going to have as a final expression. My variable term 1x minus my constant 1 and 2/3. The other way that I can do this is by combining anything similar inside of the parentheses. Inside of the parentheses, I notice that I have a constant here of 2 and a constant here of positive 3. And so I can rewrite this problem as negative 1/3 times in parentheses. Well, again, I like my variable term to be first, negative 3x. And then my constant, 2 plus 3 is 5. So inside of the parentheses, I'm going to have negative 3x plus 5. And then I can use the distributive property. I can do negative 1/3 times negative 3x, which again, I'll make negative 3x over 1. And then I'm going to do minus 1/3 times 5, which again will be 5 over 1. Looking at the first term, just like I did before, I can simplify each of these 3's down to a 1. Negative 1 over 1 times negative 1x over 1 is actually going to be positive 1x. And then negative 1/3 times 5 over 1, nothing simplifies here. This is going to be negative 5/3. Okay, so I have 1x minus 5/3, but 5/3, well, 3 goes into 5 once with 2/3 left over, so this is really just 1x minus 1 and 2/3. And so either way that I decided to simplify, I end up with the exact same answer. In my last example, I'm going to simplify the expression negative 2/5 times 10 plus 15m minus 20n. There are no similar terms in the parentheses here, so I'm just going to have to distribute. So I'm going to have negative 2/5 times 10 over 1 minus 2/5 times 15m over 1 minus 2/5 times negative 20n over 1. Okay. Next thing I'm going to do is go ahead and simplify. 5 and 10 have a common factor of 5. The 5 becomes a 1, the 10 becomes a 2. And now this is negative 2 over 1 times 2 over 1, which is going to be negative 4. Next, I'm going to simplify the 5 and the 15. 5 becomes a 1, 15 becomes a 3. And so this is negative 2 over 1 times positive 3m over 1, which is going to be negative 6m. Finally, I'm going to simplify my 5 and my 20. 5 becomes a 1, 20 becomes a 4. So we have negative 2 over 1 times negative 4n over 1, which is going to be positive 8n. Okay, and then I can just rearrange this so my variable terms are first alphabetically. I'm going to have negative 6m plus 8n minus 4 as my simplified expression.